Hello everyone, welcome you all to today's lab. This is a simulation lab, and in this lab we will see how ARP and DNS protocols travel one device to the another. So let's start. Now before beginning our simulation, you need to understand few things. Firstly, the concept of ARP and DNS. We have already learned about these two protocols in our theory classes. If I cover them here briefly, DNS returns the IP address of a corresponding URL and ARP returns the MAC address of a corresponding IP address. If the first concept is clear, the second thing you need to know is about broadcast domain. Now, to understand broadcast domain, consider a scenario. In this scenario, this circle in the left side of BRAQ router, consider them as your school friend. The BRAQ router is yourself, and the things in the right side of the router are your university friend. Now, if any incident occur in your school friend circle, your university friend circle will not know anything about the incident if you don't say the thing to them. So it's like if one of your school friend gets injured or are getting married, your university friends will not know anything about that unless you invite them to the wedding. Similarly, if PC1 wants to broadcast any message, it will broadcast every devices till it reaches the router. When the message reaches to the router, it will stop the message there and won't let it pass to the right side. So a router actually divides the whole network into two or more broadcast domain. Now moving on, as I already told you, this is a simulation lab. We need to reset the environment in Packet Tracer. As you can see, there are two icons here, real time and simulation. You need to press the simulation button. I will drag it a little bit to the left so that you can visualize the whole thing. Now this is more like okay, we will see how this simulation panel works when we move on to the lab. So what is our task for today's lab? If we go to the PDF file, down here they have written everything detailed about the stuffs in the packet tracer. Our problem starts from here. So basically what we need to do is we need to go to the web browser in this PC1 and type testserver.com and see the web page returned from this test server. So let's start. Double click PC1, go to desktop. Here you can see the web browser. In the URL, type www.test.com. Press go and minimize the window. As you can see, two packet, these are like a message icon in our phone, has appeared in PC1. The brownish one is DNS protocol and the green one is ARP protocol. So if I press this play button, one of those files will start traveling through the network. So first, the PC1 needs to know the IP address of test server, the test.com we have typed on the web browser. Now to find that IP address needs to travel to the DNS server. Okay. Now there is another catch. To travel to the DNS server, PC1 must also know the MAC address of DNS server. So what it will do, it will first send the ARP protocol through the network and ask for the MAC address of DNS server. Once it gets the MAC address of the DNS server, then it will ask the DNS server to deliver the IP address of the test server. Now I know this all sounds a little confusing, so let's start the simulation and you will understand from there. So if I press the play button, you can see that green message, what can I say, envelope start traveling. So it goes from here to here, and as you can see, finally it reached the DNS server. The router is actually just dropping the file as it is not his concern. From here, the DNS server is returning the ARP request. Actually, it is called ARP acknowledgement back to the PC1. So now the PC1 actually has the MAC address of the DNS server. Now it will send the DNS request to the DNS server so that the DNS server can deliver the IP address of test server. So as you can see, the brown file is traveling towards DNS server. Now it has reached the DNS server, local DNS server. Now the DNS server is returning the message to PC1. Let me just speed up this a little. Yes, so in this stage the PC has the IP address of the test server. Now as we have already seen that in order to send a packet or any message from one device to the another, you also must need to know the MAC address. So now PC1 needs to know the MAC address of the test server. In order to know the MAC address, what protocol do we need? We need ARP protocol. So now the PC1 will broadcast an ARP request to the network so that it can find the MAC address of test server. So let's start the simulation again. Here the ARP request traveled to the switch. The switch is broadcasting it. PC0 doesn't care, so he drops the request. It's traveled to the DNS server and the router. So DNS server also drops the request. Now here is another catch. As you can see, the packet is not traveling towards the right side of the network of the router. And why is that? Because remember, we have already talked about the domain thing, broadcast domain. So when the ARP request reach to the breakout router, the router is telling to the PC1 like, look buddy, the thing you are looking for is not on your broadcast domain. So you don't need to worry about the MAC address of that server. All you need to worry about the MAC address of my this port. I'm sending you the address of this port. So whenever you need to reach this test server which is not on your broadcast domain, you just deliver the message to me and I will look at the rest of the things. I will do all the finding things. You just give it to me and I will carry the message. So by saying that, the router is sending the ARP request back to the PC1. You all need to worry about my address and I will look at the rest. So here the ARP request is going back to PC1. So now PC1 is chill, like I have already got, I don't need to worry about the MAC address, router will look at that. So all I need to do is just pass the message to the router. So now router sends the ARP request back to this line and you can see that here is the ARP request sent by the router. So finally the ARP request has reached test server. Now test server, what will it do? It will print its MAC address and send it back to the BRAQ router. And as it is on the internet and router is connected to the internet, the BRAQ router has already got the message. Already as message, I mean that the MAC address of test server. So now earlier PC1 knew about PC1 don't right now don't care about the MAC address of the test server, because it is told that it need to send the message to the BRAQ router. So it has prepared the HTTP protocol message. As you can see, it is more bluish color. Message envelope has appeared on the PC1 and it is ready to travel to the router. So if I hit the play button again, see the message comes to the switch, then switch 1 delivers it to switch 0, delivers it to switch 1, then BRAQ router, then router sends it into the internet. From the internet, switch 2 receives it, then to the test server. Now test server already know the HTTP request, so it is actually sending the web page we wanted to see at the very beginning. I have speed up the simulation so the envelope is traveling a little faster. So finally the envelope has reached to PC1. Now if we try to see oh my god, sorry for the inconvenience. Yeah, now if we want to see the sorry again guys, I'm actually using a stupid device. Now as you can see, the window we have already minimized, the PC1 test server is already showing us the web page we have wanted to see earlier. See the test server, sorry again. Yeah, now welcome to Cisco Packet Tracer, quick links, small pages. So this is the thing we wanted to see when we typed www.test.com. And before finishing it, I need to tell you just a few things before we end up. If you press any of these links here in the simulation panel, like they're already written the type of that request, like DNS, ARP and HTTP. So just if we press this link and go to inbound PDU, we will actually see the structure of this protocol. Like in here, destination address is written as FFFFFFFF, which means that this actually this is a broadcasting message. We don't yet know the IP address of the host device sorry, the destination device we're looking for. So that is why it is written as FFFFF. And we also don't know the target MAC address, that's why it is written as 000. But we know the IP address, so we are sending this IP address here. So it's like I'm shouting in a room that what is are you the person, or are you the device who has the IP address of 192.168.10.2. So if someone replies yes, I am, then I will ask him, please return me your MAC address so that I can have a conversation with you, something like that. And if we open any DNS protocols here, just and go to, sorry for that again, I'm using a very stupid device. Yeah. uh, Sorry. Yes. So I go to this outbound, and we can see that here I have already the source IP address and also the destination IP address. Okay, so what I'm looking for is this is DNS query, the URL name, this is I'm looking for, and I want to know the IP address of this of this URL. So that's why I'm sending a DNS request from PC1 to the server. Remember the IP address of the server 192.168.10.2. So I'm sending a DNS request from my PC1, whose IP address is 192.168.10.3, to my local DNS server, whose IP address is 192.168.10.2, and I want to know the IP address of www.test.com. So as you can see, by looking at the type or the structure of a request, we can understand, or we can find the host device and also the destination device, and what the host is looking for in this query. So that would be all from this video. Thank you again for staying up till now. Best of luck.